Okay guys, today we're going to learn how to rationalize radicals in a denominator. And I'm going to give you two examples. One is going to have a single term radical in the denominator, and the other one is going to have a two term. So let's start off with the first one. And first example here is going to be 3 over the square root of 5x. Now, we need to multiply by a value that will cause the radical in the denominator to disappear or be modified. Then the only way, if you can remember, that we can change an expression is if we multiply by 1, because we're not actually changing the value of the expression, but we're going to change what the expression looks like. So I'm going to go ahead and multiply by the square root of 5x over the square root of 5x. Now, I chose this because if I multiply the square root of 5x times the square root of 5x, I'm simply going to get 5x. And I'll show you why. Because when we multiply the numerator, we're going to get 3 square roots of 5x. And then in the denominator, we're going to get the square root of 25x squared. But the square root of 25 is simply 5, and the square root of x squared is x. Our numerator remains the same. And so there is our rationalized denominator. This expression equals the same thing as our original one. However, it's in a different form because the radical in the denominator has been rationalized. Now let's look at a second example. If we had 2 over the cube root of x, we need to rationalize this denominator. However, if you notice, when we multiply by another cube root, we have to have one so that when I multiply, I'll have a group of 3. I only have 1 here. So I'm going to need the cube root of x squared. Once again, I'm multiplying by the number 1. So I multiply the numerator together. I get 2 cubic roots of x squared. In the denominator, I'm going to get the cubic root of x cubed. If I take the cubic root of x cubed, I'm simply going to get x. And in the numerator, I just bring it straight down like it was. So once again, I've rationalized the denominator. It is no longer has a radical. It is a singular x. So now our next step is to do this with 2 terms. So let me erase this. And our next one is going to have two terms in the denominator. Let's use the example 3 divided by 4 minus the square root of 5x. Now, when we have 2 terms in the denominator, we need to multiply by the denominator's conjugate. And you might remember conjugate. We did this in Unit 2. We multiplied by the conjugate in order to cancel out a radical. So we've actually done this before. We're going to multiply by 1, but 1 is going to take the form of 4 plus the square root of 5x. Notice this is the number 1. We're multiplying the expression times 1 because we don't want to change the value of the expression, but we do want to change what it looks like because we want to rationalize the denominator. Notice the conjugate, just to remind you what a conjugate is. It's the same term, except in this term it's a negative, and in this one the opposite sign. So if this is negative, then this one is positive. Only the middle operation changes, not the front term. So when we multiply, we get 3 times 4, which gives us 12. Remember, we're using a distributive property, 3 times 4. And then we're going to distribute the 3 to the positive 5x, so we get 3 times the square root of 5x. In the denominator, we're going to distribute it again. We're going to get 4 times 4, which gives me 16. And then, if you remember from when we multiplied by the conjugate before, we're going to multiply the 4 times the positive 5x, and then this 4 times the negative 5x, which is going to cause our middle terms to cancel out. So instead of having to write them down, they cancel out. Then finally we're going to multiply the negative square root of 5x times the positive square root of 5x, and we're going to get minus 5x. This gives us a new expression that represents this original one, but now the radical is no longer in the denominator. Let's try another example. This time we'll put 2 radicals in the denominator. Let's look at the example 5x divided by the square root of 3 minus the square root of 7x. Once again, how are we going to simplify this and rationalize the denominator? We're going to multiply by 1, and we're going to multiply by the conjugate that is down here in the denominator because we have 2 terms. So we're going to multiply by the square root of 3 plus the square root of 7x, both in the numerator and the denominator, because again this is 1. We multiply in the numerator. Let's do that first. And we're going to use the distributive property. 5 times the square root of 3x is going to be 5x square roots of 3. Bring down our plus sign, and then we're going to multiply the 5x times the square root of 7x. So we get 5x times the square root of 7x. In the denominator, we're going to multiply, again using the distributive property. Square root of 3 times square root of 3 is going to give us the square root of 9. And the middle terms will cancel out. And then we're going to multiply the square root of 7x times the square root of 7x. That's going to give us the square root of 49, x squared. Notice we could have actually almost skipped this step, because by now you should realize that the square root of 9 is 3, and the square root of 49 is 7. The square root of x squared is x. So our denominator has been rationalized. You may leave the numerator like this. However, you may also see it with the 5x factored out and the other terms in parentheses. I will take either this one or this one. They are both correct. However, this is a more simplified version. As you can see, the 5x that was common to both of them we removed, and we just left this in parentheses. We could have done that from the very beginning, just left the 5x, and rather than multiplying it in. But sometimes when you multiply it in, you'll cause something to simplify in the numerator, but in this case it does not. So you can go back and leave it as it originally was when in its factored form. Again, both answers are correct. Just be sure that you're able to recognize when you factor a 5x out, what you get. I hope this is helpful. And the last thing on our list for rationalizing the radicals is you need to know a checklist to be sure a radical